So starting with that first one, we want to solve for a. So don't forget, we want to circle that a, just a reminder that we want to get that by itself, and we'll draw our line of equality. And then what do I do to get the a by itself? What do I have to get rid of? I have to get rid of that negative 7. So do I do that by adding 7? No, that would be a common mistake on this one, but it would be a bad thing to do because what operation are we using in this equation? This is multiplication, so to undo multiplication we have to use division. So we're going to divide by, this is another mistake, make sure you choose wisely. What are we going to divide by here? Positive 7 or negative 7? Negative 7. Alright, so we change the operation from multiplication to division, but we have to keep the number the same. So we're going to divide by negative 7. Alright, if we're trying to get rid of a negative 7 times negative 7, we have to divide by negative 7. Okay, if this was a subtraction problem, then we would add 7, but that's the only time we would change the sign. If we divide by negative 7 on the right, we have to do it on the left. So on the right side, when those 7's cancel and the negatives cancel, what's left over there? The a. And on the left side, first of all, we have a negative divided by a negative. That's going to give us a positive. So I'm just going to cross those negatives out and forget about them. 35 divided by 7 is 5. All right, the next one we want to get the b by itself. So we'll circle that. Draw our line of equality. And I have to get rid of the 7 here also. How do I get rid of this 7? We're going to subtract 7. All right, so the opposite of adding 7 is subtracting 7, so we subtract 7 on both sides. On the left side, those 7's cancel, leaving what? B. And on the right side, we have negative 4 minus 7. So we have a negative and a negative. Are we going to have these negatives combining or canceling? They're going to combine, right? Since they're all negatives, they're going to combine and give us a bigger negative. So what is 7 plus 4? 11. And is that a positive 11 or negative 11? It's a negative 11. So if we have 4 negatives and we add 7 negatives to it, we have a total of 11 negatives. Okay, we didn't have any canceling going on there. Now for the fun ones, the fractions. The next one, we want to get the c by itself. And we'll draw our line of equality. So what do I have to get rid of to get c by itself here? That 3 over 5. And how am I going to get rid of the 3/5 here? We're going to add it, right? So that's c minus 3/5. So to get rid of it, we're going to add 3/5. Alright, so we add 3/5 on both sides. And on the left side, those 3/5 are going to cancel each other out, leaving what? C. And on the right side, can I add these two fractions together as they are now? No, what are we going to have to do? We need to get a common denominator. Anytime we're adding and subtracting fractions, we need to make sure the denominator is the same before we add or subtract. What would our common denominator be here with the 4 and the 5? 20, okay. So I'm going to rewrite these. Instead of 1/4, I'm going to have something over 20. And instead of 3/5, I'm going to have something over 20. What do I multiply by 4 to make that a 20? Okay, so we'll multiply by 5 on top and bottom, and we get 5 over 20. And then what do I multiply by the 5 here in the denominator to make that a 20? 4. So I'm going to multiply by 4 here, and I get 3 times 4 is 12. Alright, so instead of adding 1/4 and 3/5, I'm going to scratch that out. Now I'm adding 5/20 and 12/20. What is 5/20 plus 12/20? 17/20. Alright. And last thing we want to check, can we reduce this? No. In fact, 17 is what kind of number? It's a prime number. What makes it a prime number? Did you say prime or odd? Oh. I thought you said prime. It is a prime number. What makes it a prime number? No. So there's actually nothing that goes into 17 besides 17 or 1, so that makes it a prime number. That makes it really easy when we're reducing because the only thing 17 could reduce by would be 17. And I know that doesn't go into 20, so we're done. All right, how about D? I want to get the d by itself here, so what do I need to get rid of? That 3/4. How am I going to get rid of the 3/4? So to get rid of the 3/4, we're going to multiply by 3/4 or 4/3? 3/4. Alright, don't change anything. We're just doing the opposite operation. So instead of dividing by 3/4, we're multiplying by 3/4, and we need to do that on both sides. Alright, so then on the left side, those 3/4 cancel each other out, leaving what? D. And on the right side, we could multiply across, but there's something else we could do first. We can simplify first, right? So I see something that will reduce with the 2. What will reduce with the 2 here? The 4. So 2 and 4 reduced by 2 to get 1 and 2. And then also the 3 and the 9 become 1 and 3. Alright, so when we multiply across now, it's pretty easy. 1 times 1 is 1, and 3 times 2 is 6. So we get 1 over 6. Can I reduce that? No, we can never reduce a 1, right? So if we have a 1 in our fraction, we know we're done. If we had a 1 in the bottom of our fraction, though, what could we do? Yeah, we could make the top number our answer. Can I just make the answer 6 here? No. But if it was flipped, if it was 6 over 1, then we could do that. All right, 2 more. We want to get e by itself here. How am I going to get rid of that 10 over 21? We're going to divide. So this is e times 10 over 21, so we're going to divide by 10 over 21. All right, now this one's going to be a little tricky because division, well, there's a trick to it. What's the acronym that we use? Remember for division? KFC, right? So on the left side, the 10 over 21's cancel, and that leaves e by itself. But on the right side, we have 3/14 divided by 10 over 21. I need to rewrite that so I can actually evaluate that. So what does the K in KFC stand for? Keep. And which one are we going to keep? The 3 over 14. Okay. What does the F stand for? Flip. And which one are we going to flip? 10 over 21. That'll become 21 over 10. Okay. And then we change what? Division into multiplication. All right. So now that we have this as a multiplication problem, we can do it just like we did the last one. Is there anything that'll reduce here? I see at least one thing. Anybody? The 14 and the 21. What goes into both of those? 7. What's 21 divided by 7? 3. And 14 divided by 7? 2. Okay, can I cancel anything else? How about those 3's?
No.
Why not?
Because
Yeah, both of those 3's are in the numerator, so we cannot cancel those with each other. Remember, if we're going to reduce, we have to do a numerator with a denominator. Right now, those are both in the numerator. All right, so we can't do any more reducing, so now we can just multiply. On top, we do 3 times 3 and get 9. And on the bottom, we do 2 times 10 and get... Okay, just check to make sure. Can we reduce 9 over 20? No, there's nothing that goes into 9 that also goes into 20, so we're done there. Okay, one more. We want to get the F by itself here. We circle the F and draw our line, and I need to get rid of that 5/6. How am I going to do that? Subtract it, right? So we subtract 5/6 on both sides. And just like always, we have something canceling out there, and that leaves the F by itself. On the left side, though, we need to do what? We need a common denominator. What is a denominator that 2 and 6 both go into? 6. Okay, you could also use 12. So a lot of people get a common denominator just by multiplying the denominators, and there's nothing wrong with that. But there is a smaller denominator that'll make things easier for us. So we're going to go ahead and use 6 as our common denominator. If you used 12 as your common denominator, then you'll get the same answer after you reduce your fraction. All right, so what do I multiply by 2 to make this a 6? On this top one here, what do I multiply by 2 to make it a 6? 3. So I need to multiply the top by 3 and get 3. Okay, what do I multiply by 6 to make that a 6? I don't have to, right? It's already a 6, so I could multiply by 1, but we just keep that fraction the same. Okay, now we need to make sure we get this right. Is this an addition or subtraction problem? It's subtraction. So I'm going to put the minus out here, and just like last time, I'm going to scratch this stuff out so I don't get confused by which ones I'm using. So I have 3 over 6 minus 5 over 6. I have a positive and a negative. So are we going to have these numbers combining or canceling? When we have a positive and a negative, they're going to be canceling, right? So we have 3 positives and 5 negatives. When they cancel, what's going to be left? Okay, I heard a 2. Is that a positive 2 or a negative 2? Why is it negative? Because the 5's bigger. The 5's negative and the 5's bigger, so when we have the canceling, there are going to be negatives left over. All right, what's the number going to be in our denominator? 6. And are we done? No. What do we need to do on this one? We need to reduce, right? So there is a number that goes into 2 that also goes into 6. What is it? 2. What's 2 divided by 2? 1. And what is 6 divided by 2? 3. So I get 1 over 3. I'm missing something. I'm actually missing a few somethings. Okay, I'm missing my equal sign and my F. What else am I missing? How about the negative? Yeah, don't forget that negative. Remember, the negative can go up on top with the 1 here like this, or you can put the negative out in front of the fraction like that. Either way is okay. Do not put the negative, though, where? In the denominator. You should never have a negative in the denominator of your fraction.